if you're looking at the Google Doc, you should be on the 4th page right now, which is, it says lecture MM03. So I numbered it 3, but it's our 4th modeling lecture. And I said right here, we have been working with mostly business-like examples, though some may appear far-fetched. Let's move to a personal finances example or something of that nature. So here's number 1, or example 1 for the day, right? And it says, suppose we're predicting personal finances for the upcoming month. Say it's May, right? Since we're already in April. Your hourly rate is $22.05. That's actually mine at Apple. It's pretty pitiful, but there it is. But that's your gross income, and then assume 14.27% of your wages is taken from federal and 7.88% of your wages is taken from state. So this is like your regular paycheck, right? Whether you work at Apple Retail like myself, or you have an hourly wage at the restaurant that you wait tables, not including tips, or if you're at an internship, you're paying that, sorry, you're at a paid internship and you're getting paid, right? You got your hourly, and then it's not as straight as multiplying that times your hours, and then bada bing, bada boom, done, right? It's always some form of taxation taken out of it. Whereas in different countries, I've yet to work in a different country, but I'm happy to report to all of you once I do, the taxes are already superimposed to your paycheck. So when someone says, hey, your salary is this, it's already that with all the taxes taken out, right? It's not like here in the States where it's like, oh, you're gonna make 80K. It's like 80K before taxes, not after. And it's also the same reason why you're buying stuff abroad, you don't have to add taxes. It's just, that's the price and that's it. So part 1 right here, you're just going to say 22.05x, where x equals total number of hours worked per month. Now, even I went a little into too much detail here, but as long as you tell me 22.05 and some variable, whatever it may be, and just tell me what it represents, that's fine. But this is the most stretch of it. Now, the wages, there's a couple ways to do this, right? You can incorporate it algebraically, right? So 2 ways to apply taxes. Okay, first is you can incorporate, I think I spelled that wrong, sorry. Incorporate into your equation, which is this 22.05x, or just tax at the end, right? Tax, let me use the word subtract. Subtract taxes at the end. So this is whoever's preferred method, whatever you want to do it, right? At the end, at end of calculation. For anyone that's curious as to how to go about the first way, right? The numbers are 14.27, gotta add this up, 0.27 plus 7.88, which is 22.15, so right? So taxes in total are 22.15%. If it is 22.15%, that means that you're getting only you get 77.85% of wages, right? So that means that you can further take this initial one. So this is if you want to leave it as it is, and then you do step 2 here, or you can combine this information here with the taxes and this, and then that will give you this equation right here. It should be point zero, no, not 0.7785 times 22.05 x. Okay, so let me just take a quick moment to explain this. I mean, obviously you all know this, especially if you worked before ever in the States, right? That 22.05 cents is just your normal wage per hour, and that's not including taxes. That's your gross, right? And then you get tax. I just looked this up for New York State and federal, so that's why there's two numbers there. If you're getting taxed 22.15% in total, that means that you have the reverse of that being paid to you, which is 77.85%. So I did was I took that percentage, changed it to a decimal, and then I used it to multiply by our hourly rate and the number of hours you worked, okay? So again, either method works. It's just a matter of what you prefer, okay? Part 2 here, it's telling you that you have a lease for a 30-year fixed rate at 3.570%, and it's for $241,700, and then that's just, of course, a lease, which you know is an annuity, and you're solving for the present value. Now, I did do this calculation in advance, but feel free to double check me in case I made any mistakes here. But here it is written out for you. It is 241,700.0357. No need to include that extra zero. Again, I found that number off the internet if you're getting a 30-year fixed rate for a home, for example. And I also found out that there is a difference between, this is just a sidebar here. So I'm gonna just write sidebar on the difference on the side here. I know I mentioned it briefly, but there is a difference between APR and interest rate. I thought it was a representation of how it is annually. I was only partially right? So if you're curious about that, we can talk about that later. It's not going to be, of course, part of your final, and it's just a good knowledge to know what's going on there. Let me finish up this equation really quick. Okay, applying the compound period, it's 12 and 12 and negative 360. So the answer I got from this was, you know what, let's use a different color. $1,094.81. So we're going to use this right here in our model as well. Someone feel free to double check that as I start the next part. Oh wait, the next part's easy. It says you can afford to put away $200 per month. I guess I should write that. You can afford to save by putting away $200 per month. There you go. Did anyone else get this number before we move on? While I heat up my tea.
I got that answer too.
All right, lovely. All right, and then if you already saw, like I said, it's the $200 per month, right? There's nothing special there. It's just, you know, it's a constant, no calculation, but you cannot forget it in the model, right? So what does the model look like here? Your model, I'm going to simply write in all the numbers without the whole numeric versus symbolic. That's more useful when you have a lot of details going on, but this one doesn't have too many. Yeah, there's 3 bullet points, but it's nothing completely unmanageable. Okay, so again, I will show you 2 ways though. You can either use just this, and remember, I'll write it underneath the model that this is gross, right? This is not including the taxes. Minus 1,009,481. And then for those $200, let's just use purple, minus $200. And the important thing to realize here is this is without subtracting taxes. Or you can include, I already forgot the number, what is it, 7785? You include the 7785, right? Remember, I'll say it one last time. If your taxes end up totaling to whatever the number is, in this case, it's 22.15%. But even then, that sounds a little awkward. So just use a simple number. If you're taxed 10% of your pay, that means you're making 90% take home, okay? So that's the opposite effect right there, or the inverse, if you will. And let me just rewrite these last 2 numbers really quick. And then this would be your answer with taxes included, right? Taxes included. All right. Now, if I gave something like this on the final, which I suspect I don't, because that means I have to rewrite the question. Actually, you know what? I might have to rewrite a couple questions because they're not the same as in person. Either of those would be correct, right? It's just a matter of how you want to go about it. Now for the follow-up questions, right? You can see that the first 2 are a little bit of, actually, no, there's no manipulation there. They're all calculating, right? So part 1 of the questions, right? Now we're at follow-up questions. Question 1. It said, hey, assume that we work 40 hours a week, right? That's your normal full-time in the States. And then assume 4 weeks per month. How much would be, how would be made, how much, that was wrong, grammar there. How much would be made in a month, right? This is where it's beneficial to say X is equal to 40 hours, right? Times 4 weeks. So just in case if anyone's going to ask, I got the number for X because of the details that were provided. So that's 160 hours. Okay. This is why it's useful to use this formula immediately, because then you don't have to worry about doing the taxes later, right? Whereas the first one, even though that is correct, right? Since this particular problem, I'm introducing taxes and all of that jazz, you have to remember and not forget to reincorporate them into your subtraction, addition, multiplication, division, or whatnot. In this case, it would be subtraction, okay? So here we go with this one. I'm going to go just 0.7785 times 22.05, and now times 160. And then now we can subtract all of this stuff out now. 109481 minus 200. And I don't know what this answer is, so I'm going to do it with you all as well. 7785 times 22.05 times 160 minus 1094.81 minus 200. So this leaves you with 1451 and 0.738. So I would go 74 cents, right? That's how you would see it on your bank account. So now maybe this will help incite a little bit of relation, right? Suppose you make so much money and then the 1094 is your lease or your rent, right? And then 200 is what you're putting away on top of just saving your money in general, right? And then for the rest of the month, you have $1,400 to play with, right? And that could accumulate to anything, right? It could be you going out to eat or eating in or grocery shopping or cooking or, you know, getting a haircut, which I can't do right now, or going out, drinks for the night, unexpected expenses. You know, say you had to pay a fine or something like that, or you want to take a trip, right? So these numbers are way more relatable, and that's what I was just shooting for here. Now, say you go, okay, well, I'm not going to work 40 hours every week, right? I want to gauge how to go about working. And that's what question number 2 was. It's asking about break even, right? Now, question 2, this one's a little bit tougher, right? You want to go about this with, do you want to think about this before your taxes or after your taxes, right? Because as everyone knows, if you work more, you're taxed more, right? If you make a certain amount of money, a large amount of money, you're what they call in the States taxed at a different bracket, right? Tax bracket. So this one, because I just made up this example for not only myself, but for the class as well, and what I'm going to talk about in tomorrow's 311 section, you know, it's always up for debate, right? If you use the base model of either the one without taxes or one with taxes, right? It'll give you a skewed view as to how to go about it. So it's just a matter of your personal preference and what you want to understand. Just for this class, since I started with the one with the taxes included, I'm going to continue with that. So as you all know already, it's $0 equals the model. And let's just do this really quick. This implies that $0 is equal to 0.7785 times 22.05x minus 1094.81 minus 200. All right, we're going to add these to the other side and then divide. 10, not 10, but I'll just combine that right now. So that's 1200, 1294.81 equals, what's this product? $17.165925x, and then divide both sides by the same number. So that leaves us with 1294.81 divided by this product. All right, so this gives us 75.4290 blah 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 x what hours, right? So in other words, we need to must work 76 hours to break even. Now, what does this mean though? This means in context of our real world situation, right? That if you work 76 hours, you have enough to pay rent and you have enough to put money away for your savings account or however you're saving, right? But this does not include any other expense, as well as any other spending, as well as any other kind of income. So you got to be careful, right? But then you can see 76 is what compared to 160. It's definitely more than half. No, it's less than half. It's a little bit less than half. right? 80 hours, 8 times. So you can get an idea of how much you're working to see how much money you make, right? Obviously, you can always punch in a calculator and figure it out yourself, but even though we have payroll checks, whether you're picking up a paycheck yourself or it's being direct deposited, it's helpful to know what your actual rate of return is, right? That is, if you have this all built into, say, an Excel spreadsheet, which we're not going to do for a semester, so don't worry about it. But if you did, and then what happens is that you go, okay, I think I can see myself working more than however many hours, or I have time to work more hours. You can see what the amount of effort in for you working per hour is worth the extra payout that you'll get. Most times it's not, unless you do a large amount of work, right? Or you put in that much more hours. So it just gives you a nice little visual take of it. So that's that. This is break even in terms of being able to make rent or afford rent and being able to afford your savings account. Question 3 doesn't formally ask you anything different to manipulate the model too much, but it's just more about a review. You'll see one of my practice problems have this, and then you'll be able to see in the solutions too. This is the practice problem that is in the appendix section for the final. You'll be able to see what's going on there. So in this case, it says, hey, suppose for the second month, you want to take 15% of your income to deposit once into a mutual fund. But you have two options, right? You got the first one at 4.23% compounded monthly, or 4.26% compounded quarterly, and then which account should be used, and what is the second month's model, right? So that first part right there, if you don't remember, and that's okay if you don't, it's called effective interest rate, right? Effective interest rate. And then what you do is, since those are both compounding periods, right, I'm going to simply color code them so that you have option 1. Which tells you to go 1 plus minus 1. First option here tells you that it is compound monthly, so it's over 12 divided by 12, and this interest rate is 0.0423, right? And we got to calculate that. Option 2 tells you that you have still a compound period, right? If there's compound continuously, it would be the other equation. Remember, this is the 4th row in your formula sheet. This one says compounded quarterly, so over 4, and this percentage is 0.0426. All right, and if you forgot, effective interest rate, you're supposed to simply pick the one that has the highest return, aka the one that has the highest percentage. I think I talked about it a little bit when I returned your second exams, or when I was slow in giving back the exams, but then I was discussing in class. You want to make sure that you get this number written out correctly so that you can properly compare. Okay, that's the first one. And now 0.426 is with compound quarterly, because what would happen is that as soon as we get the correct setup, but then their calculator would be way off for whatever reason. Don't know what they did, but you get the idea. Okay, there are your two options. And then now you can see the effective interest rate where you have two different accounts, but the compound period is different. And now you can properly see who's going to give you the better return. Now, obviously, the difference is very small, but then when you're talking large scale, there is an apparent difference, right? And it's option 2, looks like 431, 432. Yep. So this is the one you want to use. And then even though we don't have any formality in terms of how much we're putting away or what our goal is or how length of time, right? You can still rewrite the model, including this notion of 15% of your income, right? So your second month's model will include that same 0.7785 times how much you make per hour. You're going to subtract off your rent still. Wait, what color did I write rent in? Navy. 1094.81. You're subtracting off your $200 for savings, but now you have to have an additional thing where you're taking 15% off, right? So that's 0.15. 0.15 of what? Of this entire expression, right? Because it's 15% of your income. If you're going to make an additional deposit for this mutual fund because all of a sudden you say, hey, I see myself in an opportunity where I can invest a little bit more, and yeah, my overall money that I can play with for the month will be a little bit lower, but I only have to do it for this month. Why? Because it's a one-time, or at least that's how I labeled it in the question. It's a one-time deposit for this mutual fund, whatever it is I'm talking about. So then you just tack in this same exact expression one last time, and then you'll be good to go. And for those that are, again, comfortable with your algebra, yes, you can technically not have to type in this subtraction twice and then move it to the front of the model right here and then put what percent there. If you're taking off 15%, that means you have 85% remaining. So that means you can put another multiplication and put 0.85 there as well. So either way works, but just for visual sake, let me erase that and I'm gonna just leave it like that right there. And that would be the expected answer for this right here. You would tell me that option 2 is the, higher return here. All right, or you circle it, check mark, whatever. And then the second month's model that incorporates this 15% of your income deposit is like this. And again, I know it might seem a little arbitrary to go, well, you're going to take 15%, but how do you know how long you're going to put it in for? What's my goal? That doesn't matter right now, right? It's just a matter of, can you give me a base model based on the components or parameters I've provided? And can you answer questions that follow up from them so that you can say, hey, this is what's happening, this is what's not happening. And that's our last question for at least example number 1 for the follow-up questions. What questions do we have in general for this first problem, if any? My tea got cold really quick. Let me flip back and see if anyone's typing a question. No. Okay, who's here? Let me take roll really quick. Oh, wow, there's a lot of you here. I mean, still less than half, but still a good chunk of you. I saw Natalie, I saw Tina, I saw Madeline. Terry, Julia, Lim. If I didn't call your name, I know who you are. Oh yeah, Karen. One, two, three, four, five, six, seven, 8. All right, perfect. All right, if is there anything, let's move to the second question now. So again, in our Google Doc, I don't have a full-fledged follow-up question written here because, again, thanking you for your patience. I was working on a couple of things before getting to this problem. So we can make up a few follow-up questions if we want, but let's at least get the model down correctly for summations. So example 2 tells you that you have a web page where you're making posts, right? Say it's your own blog and you don't sell anything physically, right? You're not an online retailer, but you're a blog and you sell information, right? You post on, well, whatever it may be. And that's supposed to help you generate revenue and all that jazz. So here you can see the language is still the same. So this is how you would recognize that it's a summation problem, right? Your web page makes a monthly post. You expect the first day the post to be reached by 100 people, right? And then your research suggests when a post is seen, it is shared to 2 new people the next day and thereafter. And you make $0.0023 per post viewing, okay? So if it helps, for part 1, I normally don't write it so formally as a formula, but if it helps, realize that your initial, your growth, and then money, if any. I say if any because sometimes I might do a problem where I don't have some kind of monetary value with it. So just in case. And then if it helps as well, you can write the whole alpha times beta to the I-1 here as well. Okay. And generally, I don't do this actually. In the years of teaching mathematical modeling pertaining to the summation, I just jump right into the summation. I ask students, hey, what represents what? And they kind of get it. But again, if we have to step back for a moment, we just have to remember that, hey, 100 is what you started with. 2 is what you're growing by. And you're making $0.0023 or very little money, right? So this means that your summation is I equals 1 to n, start at 100, multiplying by 2 to the I-1, and all of this is being multiplied by 0.0023. Okay, if you've written this on the backside, that would be correct as well. There's no preference because remember, multiplication is what? It's commutative. A times B is B times A. Okay. This web page, you probably have a domain name, so it has a lease, or I guess I should say your website domain name has a lease of $10,000 at 1.23% over 50 years. So you're going to have this, you know, domain name forever, more or less, depending. Or you can extend it for further, however you want to think of it. Because remember, you can't own a website, right? You have a website, but you're still paying somewhere to have it where it's your whatever.com, right? It could be your name.com, .net, .org, .whatever, or whatever idea you might have in the future. Modeling, mathematicalmodeling.com, whatever the heck it might be. So if you have any interesting ideas or future ideas, I would say go to Google domains. Don't use GoDaddy. It's terrible, right? Just something simple like Google domains or domains.google.com. See if it's available, and it's quite cheap. Sometimes it's as cheap as $4 a year, right? And then if it's a really good idea, you could just have that domain name, and then once you come up with whatever that idea is, you'll have a already website for it. So this is 10,000 times 0.0123. You can see I was very clever with the percentage there, AKA lazy. Okay. Now this lease is unique in the sense that we're going to put it over 12 still. Because like I said, it's 12 times 50, 600. leases are fair game for compounded monthly of 12, right? But I will say right here on the side, note if I provide a CP of annual, right? How do you adjust for that? You have to divide by 12. Remember how I just said right now that in the current world, if you were to quote unquote lease or buy into a domain name, right? Like say you're Tina and you want to buy tinacohen.com. Most of the time they're per year. But if you're asking for a modeling situation where it's per month, you have to divide that up, right? So if I provide the CP of annual to include in the model per month, divide by 12, okay? Just a little reminder. I don't do it often, and I feel that maybe one of the practice problems in the appendix section to prep you for the final may have discussed about that, but I personally don't recall. So I just wanted to point that out for you. I have no idea what this answer is since I was typing this at the beginning of class, so let's find that out together. RPV equals, all right, I got 10,000 times 0.0123 divided by 12. We're dividing this by 1 minus 1 plus 0.123 divided by 12 raised to the negative 600. Okay, so I got, after rounding, $22.32. So now you have both your pieces for your model, right? You got the summation. You have the monthly expense. So this one's super helpful if you want to do it symbolically, right? So the model in terms of symbol, let me rewrite that, please. I'm just gonna write it like this instead, symbolic. Model is just your summation minus the recurring monthly payment for leasing that domain name, right? If you're going to do with the numbers, so numeric model, right? You just write out everything. I equals 1 to n. I forgot what my numbers were, 102 and 0.023. I'll color code it the same, so 100 times 2, I to the minus 1, 0.0023. And then you're going to subtract off $22.32. Now, before anyone freaks out and thinks, oh, wait, how many views do I have to have so that I can generate enough income to outweigh this? Don't worry about that. I'm not going to ask any kind of break-even problem for a summation because it can change per month, right? It could be 28 days if you're in February, 30 days if you're in whatever day, 31 days if you're in December, whatever the case may be, right? But also even the fact that I can tell you or establish how many days are into it, I'm not going to go anything crazy like that because the summation evolves, right? You can start with 1 for the 1 day, the first day, of course. But then if I have you change the starting point versus the growth factor and all those things, it can get a little bit hairy. And then I think it's a little bit more involved than your usual break even for a regular linear function, right? So don't worry about that. The most I would ask for is, again, calculating for the first so many days or a certain day specific, right? So let's wrap that up really quick so that people are used to that. So I'm going to make up your follow-up questions right now really quick. So whether you are paying attention to the Google Doc or you just hear what I'm going to say and remember the numbers I tell you right now, I'm going to say or ask how much was made in the first 4 days. And I'm going to say how much was made on the 10th day. And if you recall from, what do you call it? Tuesday's lecture, right? The key words here are the first so many days. In this case, first 4 days, right? So our first question is going to be, hey, how much did you make? Excuse me, for the first 4 days. Excuse me. And that's how you know, excuse me, that it's a summation. That not only do you have to calculate for 1, 2, 3, and 4, you have to add them up at the end. Whereas the second question for the 10th day, it's strictly there. You just use the numbers, no summation, no adding involved, okay? So here is question 1 really quick. So we know it's to 4, right? So I'm gonna go I equals 1 to 4 of 100 times 2 to the I minus 1. So this equals what? 100 times 2 to 1 minus 1 plus 100 times 2 to 2 minus 1 plus 100 to 3 minus 1. Nope, I forgot the 2. Times 2 to the 3 minus 1. And last but not least, 100 times 2 to the 4 minus 1. Now, I'm not sure if anyone noticed this already, and this is definitely something I don't always teach to the entire class, so I feel like it just complicates things more, especially if people's algebra is kind of haywire a little bit. However, if you guys are keen on it, right? You don't have to write this down. What do all 4 of these terms, right? Remember mathematically, these are called terms right here. That's the first term, that's the second term right there, that's the third term, and what's the fourth term right there? And I'm gonna ask, what do they share in common? And obviously you can tell me 100 because they all have purple, a 2 because they all have green, and they all have the -1 at the exponent, which is absolutely true. Yet if you're talking about strictly algebra, right? What do they all share in common? And I'm going to tell you right now, it's the 100, right? Specifically the 100. Let me use a different color here, right? I'm talking about these guys, right? Even though they all have a 2, the number of 2s they have in total are different, right? Remember, this is 0, 1, 2, and 3. So that's not the same numerically. So if you remember a nice little thing called factoring, right, with an F, you realize that you can factor out 100 out of all of these, and you don't have to worry about multiplying by 100 until the very end. You just have to do the exponent. The same is the case for here too. If you factor 100 out of the summation, right, it will look like this. It will look like I equals 1 to the 4, and then you have 100 right here, and then you have 2 to the I minus 1. This would be the correct answer as well. Why? Because the summation, remember, only relies on the pieces or the expression of your algebraic expression that involves the variable. Where's the variable? The variable for I is right here, which means that it affects the exponent as well as the 2, right? It has to worry about the I minus 1 and it has to worry about the 2. But if you notice for 100 right here, right, there are no i's involved. That's why it can be factored out. And that's why this expression in this nice, I don't know if this is a baby blue or whatever blue this is, that would be correct. In fact, you can apply this to any summation, right? Whatever your starting day is, right? In this example, it was your post reaches 100 people. You can factor that out because that's always the starting day. Once the starting day is done, you don't have to worry about that, right? You've already lit the fire, if you will, quote unquote, right? So it actually applies to any summation for especially this class, but any summation you ever run to in the future. Not that I expect you guys to run into a bunch of summations later, but if you do, if you ever see a number within the summation and there's no variable attached to it that's relying on the indices, in this case, the I equals, you can always factor it out. But that only applies if it's multiplying, right? Factoring only applies to multiplying, dividing, not adding, subtracting. So you got to be careful with that. So if this was like 100 plus 2i minus 1, right? Not multiplying in the middle, then it doesn't work, right? It's only when it's multiplying. So if you have to remember your algebraic skills for not only distribution, which is one way, but factoring is the other way, then you can do it this way and it saves you a lot of calculations. But I digress. So don't worry about that. It's just a little bit of extra tidbit for a smaller audience here. If you utilize it or use it, great. If you don't, that's also great. It's just whatever you feel is the easiest to understand. So this is equal to, I'm just going to put a nice little orange bubble of this so it's separate. So back to our summation is equal to 100, right? Because times 2 to the 0, anything to the 0 is 1, plus 200 here. And then that's going to be multiplying by 2 again. So that should be 400. And then that's also going to be multiplying by 2 again. And so that should be 800. So in total, 8, 9, 10, no wait, 8, 9, 10, that's 1,000. So 1,500 people saw it, your post, in the first 4 days. But this is equivalent to 1,500 times 0.0023. This implies $3.45. So you can already see that if you just let this run its course for 10 days or so, which is the next question, you can see that it'll grow quite high, right? So for question 2, I asked for only the 10th day. So that implies 10th day. Let me write that in a different color. 10th day. This implies 100 times 2. So when you do a single day, you still need the 100, right? The factoring is only when it's a summation. So this is 10 minus 1. This is equal to what? 100 times 2 to the 9th, which is 51,200 people, people. And then you multiply this by 0.0023, you now have made $117.76. But here's this beauty about summations, right? Or that whole idea of additive results. This is only the 10th day. This doesn't include the first 9 days. So that's where the English is different as well, right? When you say, hey, how much is made on the 10th day, you're talking about day 10, only day 10, assuming the same rate of growth. And for these problems, we are assuming the same rate of growth, right? We're not saying like, hey, maybe the next day doesn't work that way or whatever, you know. We can't really have a proper model that follows true social media growth in whatever platform you're talking about. But for here, this is fine for now. this is how much you made for only the 10th day. It's not including the 9th, the 8th, the 7th, the 6th, and adding those all up together to give you a total amount of income. So just something to keep in mind there.
Question 1, is it supposed to be 34.5?
Is it? I probably messed up. So that's,
I got
let me make
that.
sure
I
I
don't
did
know
this
if I'm
right.
wrong.
800 plus 200 plus 500, so that's 1500 times 0.0023. Did you put 2 zeros? 0.0023?
Yeah.
Good catch. So you want to watch out for those zeros too, because sometimes I will purposely make them small, because if I say you even put $1, right? If you put $1, that means that you made $345 in the first day, and then for the 10th day you would have made $11,776. I don't know anything in the social media platform or even among influencers that make that much money that quickly. They make a lot of money, sure, via promotions and viral and all this fun stuff, but not that high that fast. It might be this quick, but not that high. So I just make these fictitious smaller numbers, less than $1, less than a penny, so that you can see the growth and how quickly it can jump up. It can have the potential to jump up. All right. What are the questions for number 2? Right. So this is a nice overview. Sorry, I didn't pause to let people ask, but I was going to just say really quick. This is a nice overview of what it looks like when you have the first type of modeling question, which is number 1, right? The numbers toned down a lot to relate to personal finances. You could see more algebra heavy, more calculations, more thinking about equations. Whereas the summations, yeah, I left out a question or two, and we can address that later at another time, right? Less calculations, more theoretical, more thinking, more of manipulating in terms of what's happening within models, okay?